There is a building technique that has been used for over 10,000 years. It requires no steel, no concrete, no lumber, no complex machinery. It builds homes that stay cool in extreme heat, survive cyclones, resist fire, and last for centuries. And Australia has been quietly sitting on the largest deposits of the raw material needed to build with it, yet you have never heard of it. Not because it doesn't work, not because something better replaced it, but because the moment this technique becomes mainstream, it threatens one of the most powerful construction industries on the planet. So what is it? Why has Australia kept it hidden? And what happens if the rest of the world finds out? Let's find out. To understand this, we have to go back 10,000 years. Long before the first brick was fired, long before the first steel beam was rolled, human beings built with the most abundant material on Earth, Earth itself, compressed, stabilized, and shaped into walls so strong that many of them are still standing today. The ancient Egyptians built with it. The Romans built with it. The Great Mosque of Djenné in Mali, one of the largest mud brick structures on Earth, has stood for over 700 years. The old city of Shibam in Yemen, known as the Manhattan of the desert, is a forest of earthen skyscrapers built in the 16th century that still house families today. In China, sections of the Great Wall were built using rammed earth techniques that have survived for over 2,000 years. This material was not a primitive compromise. It was the dominant building technology of human civilization for 10 millennia. And the specific technique Australia has been sitting on quietly is called rammed earth construction, a process that compresses raw subsoil into walls of extraordinary density, thermal mass, and structural strength. Here's where Australia enters the story. Australia sits on some of the largest and highest quality deposits of laterite and subsoil clay on the planet. These are the precise raw materials needed for high-performance rammed earth construction. The red earth of Western Australia, the ancient clay soils of the Northern Territory, and the stabilized subsoils of South Australia are so chemically ideal for this technique that builders who have worked with materials from across the world describe Australian earth as among the best rammed earth material they have ever encountered. And yet Australia has some of the most restrictive building codes on Earth when it comes to earth and construction. In most Australian states, rammed earth homes cannot be approved as primary residences without expensive engineering certifications that can cost more than the build itself. The regulations effectively price out the very people who would benefit most from this technology. Meanwhile, the Australian construction industry generates over $300 billion per year, selling the same steel, concrete, and timber-framed homes it has been selling for the last 50 years. Homes that cost more to build, cost more to run, and fail faster than the earthen structures they replaced. Here's exactly why rammed earth is so extraordinary. The core principle is thermal mass. Every material has a capacity to absorb, store, and release heat. Steel has almost none. Timber has very little. But dense compacted earth has enormous thermal mass. A rammed earth wall, typically between 12 and 24 inches thick, absorbs heat slowly throughout the day and releases it slowly throughout the night. This creates what builders call a thermal lag. The wall buffers the interior of the home from external temperature extremes with a delay of 8 to 12 hours. In practical terms, this means the following. On a day where the outside temperature peaks at 104 degrees Fahrenheit at 2 in the afternoon, the heat from that peak does not reach the interior of the home until 10 or 11 at night, by which point the outside temperature has already dropped. The heat wave passes through the wall and exits into the cool night air without ever fully entering the living space. The home stays cool all day with zero mechanical cooling, zero electricity, zero cost. And in winter, the process reverses. The wall absorbs the weaker winter sun during the day and releases that stored warmth into the home throughout the cold night. A natural, self-regulating thermal battery built into the walls of the home itself. Beyond thermal performance, rammed earth walls are also extraordinarily strong. A properly compacted rammed earth wall can achieve compressive strengths comparable to standard concrete. They are naturally fire-resistant, achieving fire ratings that exceed most modern building materials. They are termite-proof, they are rot-proof, and they are effectively soundproof. A rammed earth home is quieter, cooler, warmer, safer, and more durable than almost anything the modern construction industry builds. And the raw material costs almost nothing, because in most cases it comes directly from the site where the home is being built. So why isn't every home in Australia built this way? The answer follows a pattern we have seen before on this channel. There is no money in it. A standard Australian home costs between $3,000 and $4,000 per square meter to build using conventional materials. A rammed earth home can be built for a fraction of that cost using soil sourced directly from the building site. There is no supply chain, no materials distributor, no manufacturer taking a margin, no complex mechanical systems to install and service. The construction industry cannot profit from a home that builds itself from the ground it sits on. So the industry lobbies for building codes that make it expensive and difficult. It funds research that questions the structural integrity of earthen buildings while ignoring 2,000 years of evidence to the contrary. It trains architects and engineers in concrete and steel while teaching almost nothing about earth and construction techniques. And it works. In most Western countries, fewer than 1% of new homes are built using any form of earth and construction, not because rammed earth fails, because the system surrounding construction is designed to make sure you never seriously consider it. The irony is devastating. Australia exports billions of dollars worth of iron ore and coal every year to build concrete and steel structures that perform worse than the soil sitting beneath them. But this knowledge is not lost, and the barrier to using it is lower than the industry wants you to believe. Here is the basic principle. Source the subsoil from your own building site or a nearby excavation. The ideal mix is roughly 70% sand and gravel with 30% clay. If the soil is too sandy, it will not bind. If it is too clay-rich, it will crack as it dries. Mix in 5 to 10% Portland cement as a stabilizer. This is the only purchased material the process requires. Build temporary formwork from timber or steel on either side of where the wall will stand. Pack the soil mixture into the formwork in layers of approximately 4 to 6 inches. Compact each layer using a mechanical or manual rammer until it reaches roughly half its original volume. Remove the formwork. And what remains is a wall of compressed earth that will harden further over the following weeks as the cement cures and the moisture releases. A wall that will still be standing in 300 years, for the cost of a bag of cement and the soil beneath your feet. Australia is not unique in suppressing this knowledge. Every country with a powerful construction industry has quietly pushed earth and building to the margins, not because it failed, because it was never profitable enough to scale. We have been selling people steel and concrete for a century when the best building material on earth was always right beneath their feet. A lot of the solutions we cover on this channel share that exact same story. If this kind of knowledge matters to you, subscribing and sharing is the best way to make sure it does not disappear again. And if you want to see how this same principle of thermal mass was used to build an entire home that costs absolutely nothing to heat or cool for a full year, that video is up next.